Windhoek Mines Limited of Nambia is contemplating the purchase of equipment to exploit a mineral deposit on land to which the company has mineral rights. An engineering and cost analysis has been made and it is expected that the following cash flows will be associated with opening and operating the mine in the area. There will be an initial cash investment of $275,000 at the beginning of the project to pay for equipment and timbers. There's an initial working capital investment of $100,000, which of course is released or recovered at the end of the project in 4 years. The annual operating cash flows associated with operating the mine are expected to be $120,000 per year. We're going to need to spend an additional $40,000 in year 3 to build new roads, and the equipment is expected to have a $65,000 salvage value at the end of the 4-year project life. If Nambia has a required rate of return of 20%, let's determine the net present value of the proposed mining project and answer the question about whether the project should be accepted. Cash flows happening at time 0, which would be the $275,000 and the $100,000, don't need to be discounted back. So we've got a cash outflow of $275,000 at time 0 and $100,000 for working capital at time 0. Now the release of working capital in 4 years needs to be discounted back. We'll look up the factor, present value factor in Table 2 for 4 periods at a 20% interest rate, and we multiply the 0.482 factor by the $100,000 cash flow to get a present value of $48,200. The annual cash receipts need to be looked up for a present value annuity factor. In Table 3, we look for 4 periods and a 20% interest rate and find a factor of 2.589. This is multiplied by the $120,000 annual cash flow to get a present value of $310,680. The cost of the road in year 3 is a single cash flow and will be looked up in Table 2, and the present value factor for 3 periods and 20% interest rate is 0.579. Multiply this by the $40,000 to get a present value of negative $23,160. Again, this was an initial cash outflow. The salvage value at the end of the project is a cash inflow. We'll look up the factor in Table 2, 4 periods and 20%, and multiply the factor of 0.482 by the $65,000, and we get a present value of $31,330. We sum together the present value of all the cash flows, and we find the project has a negative net present value of $7,950. And since the project has a negative net present value, this means we would reject the project because we don't earn the company's required rate of return of 20%. Let's go ahead and take a look at the cash calculations using a financial calculator. Again, the time 0 cash flows, the cost of the equipment, and our initial working capital investment don't need to be discounted back. The release of the working capital in 4 years, though, will be solved for in our financial calculator by entering 4 periods, a 20% interest rate, 0 for the payment, and $100,000 as the future value that we expect to receive at the end of 4 periods. Solve for the present value and get $48,225. Now the annual cash flows, they will be entered as the payment field. So again, we have in 4 for the number of periods, a 20% interest rate. Now we have $120,000, the annuity coming off the project as the payment, and 0 for the future value. Solving for the present value, we find $310,648. Notice these amounts are slightly different than the amounts we get from using the table because the tables involve rounding. The cost of the roads in 3 years will be entered as 3 for the number of periods, 20% for the interest rate, and again 0 for the payment because this doesn't involve an annual cash flow. And then finally, $40,000 for the future value. We get a $23,148 present value. Finally, the salvage value in year 4. We have 4 periods, a 20% interest rate, 0 for the payment, $65,000 for the future value, and then we solve for the present value and get $31,346. Summing them together, we get a net present value of negative $7,928. And again, we reject this project because it is a negative net present value, and our value is again slightly different than the value we get using tables because the tables involve rounding.